Hi, welcome to another video podcast. We're going to have a look now at Feynman Diagrams. This is a general introduction to Feynman Diagrams. I'll shoot another video which will tell us about the specifics of the particular Feynman Diagrams that you need to know about. Just looking at that, I guess it could do with an extra A. If you're taught by me, you'll know that that's quite common for words to need a bit of modifying after they've been written. So before we go any further, we need to have a think about exactly what a Feynman diagram shows us. It has two axes, even though they're not normally drawn in. It has a time axis and it has a space axis. So as we move in this direction through the diagram, we're moving through time. As we move in this direction, we're moving through space. So we'll have a little look at thinking about recording some ordinary everyday objects on a Feynman diagram. So if we can imagine somebody just cycling down the road on their bicycle, then they might look like this on a Feynman diagram, assuming they're moving at constant speed. As we go through time, they move through space, and if they're going at a constant speed, the amount of space they move through, the distance they move, is the same in equal time intervals. If on the same Feynman diagram we had a car overtaking the cyclist, it might look like this, and here we can see this is where the car is overtaking the cyclist. Moving on to another everyday event, I won't draw in the axis this time, so we've still got space and we've still got time. We could imagine a series of events being recorded so they look like this on a Feynman diagram. If you've been doing the course with me, you might recognise that it's a tennis match. Okay, here we have a serve, return of serve, another return, some shorter shots here, maybe a long shot out at the end. Let's try and apply that now to a simple particle situation. We know from basic knowledge of physics that two electrons, two equally charged objects, will repel each other. And in classical physics we simply accept that they exert a force on each other. But particle physics attempts to explain the origin of that force, and that's really neatly represented on a Feynman diagram. Initially, and we tend to draw Feynman diagrams starting from the bottom up, because the bottom of the diagram represents the beginning of time. We have two electrons and they are moving towards each other in space as we travel through time. Because they repel each other, they will then later start moving away from each other. So what causes them to start moving apart? And in particle physics we use a wiggly line to represent a boson, a force carrying particle, and we say that the electrons have exchanged a boson, a photon, a force carrying particle here, and that's caused them to start moving apart. So just notice, real world particles, straight lines, wiggly lines are used for force carrying particles, bosons. In the next video I'll run through the Feynman diagrams for beta decay and some of the other ones that you need to know. Thank you.